Today I'm going to show some of the advanced abilities of the HBM eDrive power analyzer. I was recently given a cool set of data showing a change in inverter switching control, which is shown on the screen, and I thought it was a really good example of how eDrive goes above and beyond a standard power analyzer by not only collecting high accuracy efficiency readings, but also recording raw data and performing real-time calculations. Here on the screen, I have a snippet of a data segment showing three-phase currents in red on the top and three-phase voltages shown on the bottom. These are coming out of a three-phase inverter that are feeding a traction motor. So on the bottom, you can see on the left of our control change event that we have a high-frequency PWM switching control, that this is operating at about 16 kilohertz. And then on the right, after the control change, we have our 6-step control that's operating at about 500 hertz. And these controls are shown really well in the current output. During the PWM, we have a really nice sinusoid, very clean. And then after the change to 6-step at the lower frequency, we have this really jagged, high harmonic looking current waveform. So all this data is being collected at 1 megasample. And while we're collecting that data, there's an onboard DSP in the data acquisition system that is also doing real-time calculations. So these real-time calculations include RMS, voltages and currents, power, efficiency, space vector, which is shown here, DQ0, and then user-defined formulas. Then these real-time calculations, or the raw data calculations, can be displayed or sent out on an EtherCAT bus for feedback, comparison to control, hardware in the loop. Here I'm showing the space vector transformation, and on the left I have my alpha and beta currents versus time. So on the top we have the whole data segment, and then on the bottom we have just a snippet. You can see in the alpha and beta we have those really smooth current waveforms during the PWM control, and then again we have that just really jagged, nasty current waveform after the PWM control. And then on the right, I have my alpha versus beta display. So over a period of time defined by these little bars up here, we're showing how the control looks. So we see we have this really nice sinusoidal waveform as displayed by this circle well within the borders of the control hexagon. And if I play this data back, we can see it follows that nice waveform circle until we get to the 6-step, in which case we go out and we're actually banging against the corners of our control hexagon, but still staying within the bounds of the control operation. So if I stop that playback and I go to the transition, which might be the most interesting part, I can see that I have my nice circle during my PWM control, and then when I switch to my 6-step, my control goes out of bounds of that circle, goes way up, bangs off one of the walls of that control hexagon, catches itself, and then goes into its 6-step operation without losing control at any point or going into a unpredictable region. So I think there's a lot of power in displaying this and how you handle those transitions. This is as far as I'm going to go with this video. If you have any more questions or would like to learn more, please reach out to me. My name is Mitch Marks, and thank you for watching this video, and hopefully I will have some more out soon.